Okay, video 27. So the first thing we're gonna do is we're gonna need to create a new function. So this is our net force function. This returns a vector, but for right now we're gonna need to return a voltage, which is a scalar. It's just like an integer. And if that's negative, that means let's see. If I look at this right here, so my voltage in all the red areas is positive. My voltage in all of the blue areas is negative. So that's what I need to check for, and I'll do that using this V equals KQ over R, which is very similar to what we have here with our net force at position. I guess that's more of like net field at position because I'm calculating my E field. But yeah, so let's do that. So I'm gonna have a function called voltage at point, and it is going to be very similar to this right here. Only difference would be that I'm using a voltage. I'm not going to use any vectors anymore, so I'll get rid of all of this. I'll say voltage is equal to 0. So I'm going through all of my charges. My radius is the same. Here, I guess I'll just call that V for now, so that's my K, that's my Q divided by R. So KQ divided by R, that all looks good. I don't need any of this theta stuff, and I don't need my vectors and everything. Then I could just say voltage plus equals to V. And then I'm going to return my voltage in the end. I need a position here. Position, because that's the position I'm going to be kind of calculating. That's my point right there. I guess I called it point before. I can call it point again. So that gets my radius and everything. Okay, that all looks good. So now if I say voltage at point and I give it a vector, let's go with like 500, you can see I have this negative number, which makes sense because the only thing I have on the screen here is negative. If this is positive, okay, so if I look at all of my charges, I have 2 charges. One of them is at 200, one of them is at 500. So if I'm closer to the 500 one, I'm gonna have a positive voltage, and if I'm closer to the 200 one, I should have a negative voltage. You can see these are also very small numbers, so I could just adjust my K value here to kind of make up for that almost. Yeah, that looks better. Okay, so my voltage at point is working. The reason I need this is so that I can decide if I will be drawing in a blue or a red circle. Okay, so I said when I'm displaying something right now, I just have it as a default set to show me a white line. But now I can create a variable. I'll call it voltage, and I'll set that equal to my voltage at a point in this. So for that, I could just say line 0, I think. Because, yeah, so the line is going to be this whole line, and the first index in that is just going to be a single point on it. And then from here, I will say if this is a new kind of if statement. I use it a couple of times in my code, which I've in the code for the simulations, but it's just cool to know about. Also, I'll create a variable called color, and I'll set that equal to an if statement, but it's a weird if statement. So I'll say if voltage is greater than 0, and I have that question mark, which is like, I don't know, I'm asking a question. Is my voltage greater than 0? If the answer to that is yes, then I want to say red. So my color is going to be red if my voltage is greater than 0. If it's not, I can say blue. It's a very weird kind of thing, but it saves space, I guess, and it also, I don't know, it looks kind of cool. Let's see what that looks like. Okay, so that's blue now. If I have a red, yeah, okay. So now I have all of these red things on that side and blue on that side, which is kind of what I'm looking for. So that all looks good. And yeah, I guess if I have a dipole right in the center of this, there should be a line where my voltage is 0. And because of this, it would be blue, but it's very hard to click on that line specifically. And I could just say, okay, this kind of defeats the purpose of this kind of if statement because that only has like 2 options. So I could just say if voltage equals 0, I will say, here's something else I can do, is I don't actually have, if I just have a 1-line if statement, I don't need to have those curly brackets. So then if that's true, I'll say color equals white. And that's another kind of if statement that I can make. Okay. 6 minutes in. Okay. I kind of sidetracked, but I think that's okay. In the next video, well, not in the next video, let's try and do it right now. Let's try fill out this gap that's left here. How are we gonna do this? When I'm getting my field align points, so this stop only happens when in these cases, when you can see I have this tiny gap here. When I don't have this gap here, like in this first case, or if I have like a whole bunch of like loops around the charge, that's when I have my iterations that kind of times out. But I could say if stop, so if any of these cases out here is true, I'm going to add this. So if I started on this position and I went all the way around, once I get to the end here, I'm just going to re-add my starting position to this, to the array, but at the end. So it's going to start and end at the same points. And to do that, all I have to do is push the starting position. And let's see what that looks like. Okay, yeah, so you can see now I have something that it kind of looks crooked towards the end, but for now it kind of works. And yeah, if I wanted to improve on this, I could if I upped the amount of like segments that I'm making to 20, and it's gonna sound weird, but if I make this like 0.5, it's kind of sounds weird because I'm talking about like my magnitude here. I was talking about it as pixels, and so if I was to create a vector that's half a pixel long, that doesn't really make sense when I think about like physical pixels, but like it's almost like a unit of measurement. That should be fine. And you can see that should so this is going to increase the accuracy of my lines here, and so that kind of bump that I have left over isn't as severe. So if I maybe up this to 100, which is kind of overkill, and I make that a really tiny vector, now it looks like I have a perfectly smooth line. And yeah, that actually all looks good. If I add in another charge right here, do I have something that looks like field lines? It looks like I do. I still have these gaps, which just come from the fact that if I'm starting right here and I'm going all the way around this entire thing, by the time I get back, I guess my recursion loop is ending. this recursion loop. I could increase that limit to try and get rid of those cases. And yeah, that all looks pretty okay. Yeah, what else do I need to do with this? Okay, I still have these cases. An interesting challenge for this, which is what I actually ended up doing with the simulation here, is, so right now I'm only starting with this get line points thing right here. When I click somewhere, I'm gonna kind of head to the right and get all of the points are along the circle starting to the right, and then try make it back to the original position. Something you could try would be, what if when I click on a certain point, I kind of branch out in both directions, and I'm looking for when these so I'm gonna have like almost two independent lines, but when these two independent lines kind of get close to each other, that's gonna be my like stop case that I have right here, and that's gonna get rid of some of this stuff with like having this not really loop back around, but because now I'm gonna be going off in both directions. I'm not gonna do that in these videos. It's just a challenge. It could be interesting to try and do. But yeah, with that, I could say that we are done. I'm at 12 minutes and I just thought of something. Let's try this really quick. So you can see here I have with voltage stuff, I also have, okay, actually we'll do that in the voltage video. So for now we're done with equipotential lines. Now we will move on to the voltage, which I think is the last kind of thing we need to do. So I will see you in the next video with voltages.